Hi, y'all. Today I want to talk with you a little bit about water in Northwest Arkansas, but mostly and specifically groundwater. But before I get around to groundwater, I want to say a little thing about this map that we're looking at. Now, when you look at this map, the first thing, or I should say, the thing that dominates the view there is probably the urban areas. I've got the city limits are colored in yellow here. So that's what dominates. But I would say the second thing that you notice when you look at a map of Northwest Arkansas is this just to the east of urban Northwest Arkansas. Beaver Lake profoundly has profoundly affected and continues to profoundly affect the fortunes of Northwest Arkansas. Now, of course, like most of our Corps of Engineers lakes in Arkansas, this was built as a flood control reservoir. So it was not built for water supply, but that was a very beneficial side effect of having the lake there, is that it's this enormous, reliable water supply. Northwest Arkansas could not have grown up to what it has today without having this enormous, reliable water supply. So everything comes back to Beaver Lake. Almost every one of these yellow-colored urban areas gets their drinking water from Beaver Lake. But if you happen to live in areas outside of those yellow areas, then there's a really good chance that you're probably getting your water from wells. In other words, from groundwater. So I want to talk a little bit about this, but also want to give you a little bit of trivia about groundwater and Arkansas. Click for my next slide. So this figure is a little bit old, but it's also still valid. The rankings are pretty much still there or still legit. When we look at the states that use the most groundwater, the top states for that, then we can explain several of these pretty easily. California and Texas have, number one, a huge population. So this is not per capita. This is just straight bulk groundwater withdrawals. California and Texas have large population, and they're both agricultural juggernauts. So it stands to reason. Well, let me give you a third thing about them is a good deal of both of those states are arid. They don't have an abundance of surface water, the western 2/3 of Texas and extensive parts of California. So, of course, they have to use a lot of groundwater to irrigate their crops. With Florida, it's kind of a weird reason, is that there are no major large rivers that flow from the Appalachian Mountains down through Florida. They don't have a lot of major rivers, so there's not just a whole lot of surface water present in Florida, and they're surrounded on three sides by salt water. So what are they going to use? They're going to have to use their fresh groundwater. Nebraska, we can go with agriculture and arid areas, but the surprise on that list is Arkansas. Arkansas sits at about 5th. We can look at that in another way by looking at the next slide, and this is the same data presented in a little different way, and it is California, Texas, Nebraska, and then Arkansas. 4th in groundwater withdrawal. Arkansas is an agricultural state, but they are not the juggernaut that Texas and California are, and they're also decidedly not an arid state. So what gives there? Why is Arkansas surprisingly 4th in groundwater withdrawals? Well, many of you know this already, but in a word, it's rice. So Arkansas leads the nation in rice production, and unique to crops, to most crops, rice requires flooding the fields. Most other crops don't require near that much water. So even with all of the rivers flowing in eastern Arkansas, we cannot depend on the year-round flow from there, and we have to pull from the ground. So that's an interesting bit of trivia. It's our rice production that makes us such large groundwater users. Our municipal use is dominated by surface water. Okay, so when we talk about groundwater for the most part does not exist in big underground lakes and big underground rivers, big void areas that are filled up with water. No, it exists in small, I dare say, tiny spaces in between sediment grains for the most part. And because of that, it travels a lot more slowly than surface water. And this results in several differences between groundwater and surface water. So we often talk about these like they are different resources, but it's also really important for us to think of them as being linked. One of them is always flowing into the other. Groundwater is flowing into rivers and streams and ponds and lakes and ponds and streams are losing some of their flow to groundwater. So these are very, very closely linked. One of the results of this is that if one of these sources gets contaminated, then the contamination will invariably reach the other one. So I want to talk a little bit about it, just in case I did not get to talk about this during the actual Master Naturalist presentation. I want to give you an opportunity here. If we could divide groundwater regimes into two categories, we could say karstic and non-karstic. And so what we mean by karstic is that the ground is full of really big holes and that groundwater travels rapidly through those subterranean systems. And the turns that it makes are really unpredictable. And you could have an abandoned cave passage that has no water running through it until maybe the ground fills up during the wet season, and this passage is completely full, which raises the level in here and in here. And so then we do have water coming out of here in the wet season. So maybe that dry cave is not a good place to store carcasses or something that might lead to contamination of the water supply. So that's what it looks like underground in karstic areas. This is what it looks like underground in karstic areas. This is in Bella Vista. This is right across the street from McDonald's. If you keep going on to the left on this road, Peach Orchard Road, you wind up at Lowe's. So you may be familiar with this area. This area was exposed by blasting. It was exposed by blasting and heavy machinery in order to either build or widen Peach Orchard Road here. But when they did so, they daylighted several vertical conduits, basically several caves that were completely obscured until then. Well, if we go up close to one of these caves, then we see that you can actually fit several people inside this. These are large vertical underground chambers. These have been exposed. They've been daylighted, but they are really large. And so imagine water from the surface encountering this and traveling through. There's nothing to really slow it down. So bottom line, in karstic regions, groundwater travels really fast. In non-karstic regions, it tends to travel much slower, several orders of magnitude slower at that. So let's have a look at this from our geology textbook. Sewage, and this could be animal sewage, it could be septic systems or whatever. When we're in non-karstic situations, then the sewage is discharged after spending some time in the tank. It's discharged into the ground, and then because this is flowing through sandstone, remember those tight spaces between grains makes the water basically have to travel a maze with lots of choke points. So it travels really, really slow, and this gives bacteria enough time to metabolize the human waste. So that by the time this water reaches the well, it is largely purified. Now, this slide is misleading because it says the sandstone purifies the sewage. The sandstone is absolutely not doing the purification. It is the microorganisms that are already living down there, and we're just upping their food supply. But the key for them is that it takes them time to do this work. They're microscopic, and their populations are low until you give them food, and then they get bigger populations. But still, if you think about your pet going potty in the backyard, you come out the next day, that's still there. You come out the next week and it's still there. But if you come out in 6 months, it's gone because it has been decomposed by microorganisms. Same ones that attack that at the surface are attacking it in the subsurface. And this will work as long as there is enough time. But if the subsurface is karstic, then as you can see, there is nothing slowing down these contaminants. Karstic terrain is a horrible place to put septic systems. The contaminated water does not slow down and really quickly finds its way to surface water. So bottom line is, I'm pretty sure I did talk about during the Master Naturalist program, at least that was my plan, is that a good deal of Northwest Arkansas is in fact karstic or potentially karstic. If we could go back to that first slide, you could draw a line right about, just really roughly, between Springdale and Fayetteville. And most everything north of that line has limestone bedrock and is potentially karstic. South of that line, we have a lot more shales and sandstone, which slow groundwater down and allow for better purification. But above that line, we have to deal with the karstic terrain. That's it.